Okay, let's get started the digital design and visualization. Today's lecture, okay? Lecture first today, lecture first and move to the some details, technical aspects of the courses, how to access the network, how to submit your file, and we have course website and some community network group, SNS. I'll let you know some details and how to do some technical things such as lab exercise, submissions every week, okay? Anyway, lecture first, digital design and visualization. The class name is the topic and title for today. Here I simply list up what to do today, okay? We're gonna have a lecture, 1.5 hour probably lecture. And we need to share the ideas about technical note and technical setup issues. In the lab exercise, very simple, 2 things we need to do. First thing is installing 3D Max design and some associated things. Second one is you first use 3D Max without experience. Even if you are not able to do something with 3D Max, just follow my instruction today. And you're gonna create very photorealistic and decent visualizations today anyway. Submission is that one, 3D Max mental array render image, okay? So requirement at the end, on the shared folder, under your name folder, okay? JPG image file based upon the lab exercise number 2. Try your best, okay? Best render scene. So the network access, quick review, course web. We're gonna do this after the lecture, okay? Of course, installation. Okay, let's move to the lecture. Before getting started, today's lecture, I like to bring your attention using an example, okay? An example from graduation work. The title is here, Brain to Brain. The reason why I show you this example is it doesn't mean that this is sort of best award-winning graduation work or something. It's just plain one of the design representation, design presentation, design visualization. So how it composed of something. This is so-called title page, okay? Brain to brain, title text, and some brief text about this content, the design approach, with some background image, okay? Some project background description. Actually, we don't need to know the details. We don't need to know the inside of this content. Actually, the background of this project is there is a space remodel for young people, kind of 20. They are postgraduate, after graduation of the colleges, what they do. Because of some social problem nowadays we encountered in Korea, they got some less job opportunities and some unstable job opportunities and some status problem they encountered, like you guys, okay, after graduation. So they want to try to make some type of spaces for them, okay? But we don't, I told you, we don't need to take care of details. My point here is just visualization, representation. Lots of graphical notations, background images, pictures, reference images, sometimes map images, okay? Floor plan, site plan, some reference picture, and lots of diagram images or some geometry transformation and so on. Their design concept is something like this brain structure or some inside of the brain cells or whatever, okay? Anyway, in their development, they try to make existing buildings geometry and transformation, interior aspects, and those 2 things going to be sort of main interior field for this building, something like this, okay? So lots of elevation looking images and so on. 3D render images, floor plan images. But take a look, what is this? In this page, some text, okay? But textual information without any visualization. But actually, take a look this one. Lots of reference pictures, floor plans, reference image taken by someone else or designers, students, 3D computer render scenes, okay? Line stroke images, line drawing images. Take a look. In this kind of visualization, what if we don't have visual? What if we don't have some computer-generated images, pictures, renders? Of course, if you read the text, you can figure out what is this design. But actually, it's not easy. What you need to do is provide a bunch of reference images in order to figure out, okay, about what? About this design. More render images, 3D visualizations, sometimes line drawing, okay? Sometimes some composed, Photoshop edited, sometimes just render scenes, and so on, okay? So the reason why I show you this image series of design representation is a little bit put more emphasis on visualization. Okay, what if there are no renderings, no computer visualizations, sketches, 3D floor plans, or even this kind of line strokes, only text, or some other type of media? It's not easy to figure out design. Okay, that's the point. Okay, what is the essence of design? We are dealing with some design computing. Okay, we are not going to learn how to develop your design or how to expand your design ideas. We are not going to deal with some design studio related issues. We are going to deal with some design computing issues, okay, technical aspects of design. Even if technical aspect of design tools, whatever, we need to figure out some type of quantitative approaches regarding design and design computing. So actually, I showed you this one before, the definition of design. Actually, it's not easy to define design. There is no such effort or no 100% sure definition about design, okay? Of course, there are amount of design definition or design description. Big guys, big designers, they tend to say something about design, okay? But it's their perspective, not yours, okay? So that's why I want to show you this one of the definition. This one of the definitions from researchers in design computing domain. They define design using those terms, structured arrangement of design units. Very simple, okay? Structured arrangement of design units or design elements. What is design units? What are design elements? First one, physical element that forms a design. Second one, an element of design that a designer can cognitively deal with. So what is the number one? What is this? Something visible, okay? For architect, interior designers, number one could be floors, doors, wall surfaces, building facade, windows, furniture, and lots of design-related elements. What is the second one? What this means? Some cognitively deal with things, something invisible. What is invisible in your design? That is design concept, okay? Design concept usually something behind your design, okay? Your visualization is very explicit, but this one is something implicit behind your something, okay? Sometimes you can deliver directly your design concept to your design physical elements, but anyway, something behind something cognitive things, they are anyway one part of design units. Okay, that's my point. So what to visualize? Both of them. Okay, not only focusing on the first one, physical things. I like to let you know, and I like to put more emphasis on some second one, design concept, so-called diagrams, something concrete, something abstraction, okay, and so on. What is designing? Design elements making plus something process, okay, some time axis. An act of creating and elaborating a design. So designing is equivalent to modeling a design model, okay? You have your design idea, very creative and unique idea. Let's assume that you have idea, okay? Design process simply means making your model. Your model, clay model, foam board model, no, computational model, okay? In this class, usually, okay? Sometimes you use SketchUp. In that case, this one going to be SketchUp model. In this class, 3D Max model, 3D Max file, okay? Next semester, if you learn Revit, that's going to be Revit model, okay? If you want to use ArchiCAD file, or Rhino file, Grasshopper model, whatever it is, that's going to be your computational model and digital design representation, presentation, things, plan, 3D, sketch, animation, anything for design representation can be extracted from your computational model. Okay, what if we don't have this model? From your idea to your sketch, from your idea to your 3D model, floor plan. Amount of arrows directly from your idea to final outputs. It's really time consuming, repetitive, and tedious, okay? You have to work 24/7 only for your design development. But thanks to this computational model, you can extract anything you want based upon very well-defined and well-structured model, okay? So if you choose this model, very low quality application or very easy to use tool, SketchUp, or if you use ArchiCAD or Revit, which one's better? Because of different capability and capacity, of course, the better one, the better, okay, for your final. I mean, your design, representation, and visualization. One source, multi-use, okay? Computational model to your presentation method. But from your idea to your computational model, if you change your mind, if you update your idea, you don't need to update plan 3D pictures, sketch animation, whatever, okay? Only one thing, okay? Your computational model should be updated, okay? This process. And then your material for design representation, presentation going to be extracted, okay? Here is the very important reason why you need to use powerful and something realistic computer software or some model generator, okay? If you have more information, the term more here means amount of related information regarding this building, so-called building information. That is why building information modeling is the way to go. This is the next semester's topic, a little bit in this class, okay? So designing is equivalent to modeling a design model. What's next? Design idea from your head. No one can see your idea. No one can open your brain, okay? No one knows your design before you made something, okay? Create model and extract visualizations, design visualizations. So what's next? Actually, design aims to be realized in real world, okay? in real world. But in school, in your design studio, it's very expensive. But that's not the only one reason, okay? Very expensive, time consuming, and there are amount of more people we need, okay? Anyway, design visualization is usually the final stage in design studio. Of course, design critic or some design competition, evaluation, lots of things we have, but anyway, they are totally based upon your visualization stuff. So, design is going to be realized if it is well visualized, attractive, convincing, feasible. If your design is not attractive, your owners, public, other people not going to pay the money for realizing this building, okay? It should be attractive, should be convincing. What is the term convince means? What is the term convince means? Convince. What's convincing? The meaning of convincing. No one knows? Trust? Okay, good. Able to understand. I'm not sure it's 100% same to convincing, but anyway, able to understand what? Able to understand that it is good design. So, the process of design is process of this one, okay? You should be able to convince, understand that other people believes that your design is good design, okay? What if you failed to convince your instructor in your design critic? If you fail to make it convincing, how to make others, other people, general people, public people, someone who gonna use that building design in the future, okay? So design process simply means some type of convincing process to others. If you convinced 100%, you only, that is not a design. There is a good term for that one. That one is art, okay? That is art. But this is design. Supposed to be convinced by others, not you, okay? Okay, that's the difference between art and design. Anyway, your visualization, kind of, it's really, really important. And then on-site construction, pre-prep, shop, prototyping, and so on, they're going to be used for this one. But we are focusing on this area only in this class. We are dealing with geometric modeling and visualization in this course. Digital design and visualization. So-called geometry-oriented approach to the design. So what is geometry-oriented approach? What else? What else? What is not geometry-oriented approach? Let's quickly take a look at the history of design, history of architecture. Architectural design versus construction. As you know, this is Da Vinci drawing, okay? Vitruvian Man as reflecting Vitruvius, okay? Marcus Vitruvius Polio is the man around 2,000 years ago, okay? He believed as the first architect, first architectural designer. He invented floor plan, elevation, section, something like standardized drawings in architecture domain, okay? So-called plans, elevation, perspectives to convey design intent. Very typical type of drawings invented by Vitruvius, okay, 2,000 years ago. 400 years ago, 500 years ago, 600 years ago, in Renaissance area, Leon Battista Alberti proposed separation between design and construction. What this means, what this mean by, before Alberti, design and construction, they are integrated, okay? In other words, I told you in your design studio, your final goal is design representation, design presentation, design visualization. You are not in charge of making them realized, okay? How that possible? Because Alberti suggested we have to differentiate the intellectual task of design from the craft of construction, okay? When 600 years ago, compared to long history of human beings, 600 years, it's really short, okay? Not that long. You have to be aware of this historic thing. Modern architecture, so-called modernism, from this phrase, form follows function, coined by an architect, Louis Sullivan, 100 years ago. 50 years ago, the first CAD tool has been invented, okay? So-called 2D CAD system. But nowadays, building information modeling, the most advanced CAD systems, what we are dealing with at least 2D CAD or 3D visualization in BIM domain. Anyway, it's not a long history thing. Compared to human history, several hundred thousands of years, but computer-aided design, so-called CAD or 3D computer graphics, digital design, its history just begun, okay? 40, 50 years. How about you guys? 2 years, 3 years, 4 years, okay? So, this is a brief history of the architecture, design, construction, something. Let's talk about the history of CAD, history of computer-aided design. Take a look. This is the original, conventional approach, history of computer-aided design. Take a look. Our current interest is here, actually, geometry-oriented approach to design. Take a look. There is a box. What to know for making this box? We have to define vertices, their connections, okay? As a result, edges, okay, lines. At least 3 edges going to create one face, faces, polygons, surfaces, okay? So, what if you wanna transform the shape of this box? You have to control one of them, okay? Vertex, edge, face, polygon, and then you can change the shape, okay? That's the fundamental mechanism of geometric modification in 3D Max. 3D Max, Rhino, SketchUp. But in SketchUp, there is no way to control vertices, only edges and faces. But in 3D Max, you may find out the name listed here in your modification tab, in Edit Poly mode, and so on. You're gonna learn how to elaborate, how to control them. Conventional CAD system only deals with geometry. Because people believe that geometric shape is all about design at that time. But nowadays, I told you, there are a lot more things. Geometry is very important, okay? It's important, critical. But it is just a subset of design, not everything, okay? So what's next? Let's take a look at this one. What else except geometry-oriented approach? This is building object-oriented approach. Take a look. Our next topic, BIM, is here, simply described. Here is a site. Take a look at this notation. One site has one dot dot star means, this notation means one or many, okay? So one site has one or many buildings. One building has one or many floors. One floor has one or many spaces, rooms, okay? How about this? One or many spaces going to be grouped by zero or many space group. How about this floor space? How about circulation space? How about building common area? How about interior architecture design spaces? How about nutrition department spaces? They can be grouped, okay? How about interior facilities? Computers, desks, chairs, they all one part of the space, room, okay? But actually, take a look. Yellow part is our main subject, our main object. But actually, in real world, there are lots of structure, okay? Slab, ceiling, roof, beam, column, foundation, all they are something visible objects, so-called structure. How about opening? Opening could be one part of wall. When you have opening, you can place windows or doors, okay? So this is the structure we have. The white colored part is something visible, structured elements, okay? Actually, yellow parts, they are sometimes not visible or sometimes not explicitly well defined. They are something conceptual objects, okay? Sometimes they are some group of objects. That's my point. How about this approach? Which one is looking advanced, looking realistic? Okay, can we create automobile, cell phone, smartphones based upon this approach? There is no such things, okay? Simply because this is building information modeling approach. But actually, take a look this one again. This is not just for building. What if you want to create very well designed your own automobile, your own smartphone products, your design things, your clothes, your monster for your game, whatever it is. You can design anything because it's geometry-oriented approach, okay? General purpose. Something has geometry. This is fitting every object in the world. But this approach only available for buildings, okay? For the building. That's the difference between those two approaches. But another important thing you have to know is they are not separated. They are not something separated. Let's take a look at this one. This is conventional geometry-oriented approach. Think about the floor plan. You draw something like this and you say this is your design, okay, floor plan. There is a rectangle shape and you put office label. And people can be aware of, okay, there is an office. How about computers? Computer doesn't know what is that, okay? Computer doesn't know what is this office. Just it represents office label on top of this rectangle shape. That is polygon, okay, polyline. That is why we say dummy geometry, okay? It's not smart, not intelligent, just geometry. But take a look at this approach. Space object in BIM model. It has amount of space and building related information. How about entire information we had before when CAD system? They are just one line of this information. 3D geometry data, geometric information. This is still very important in this approach. But my point here is, it is just one part of it, okay, not 100%. But before this approach, when we are using just CAD system, it's everything about your design. But nowadays, we have a lot more additional information. So my point here is they are not totally separated, okay? This one is totally a subset of this information modeling approach. That's my point, okay? Okay. I showed you this one before. We are aiming to design using design computing technologies, okay? But visualization is the subject for this semester. Focusing on visualization before handling BIM, okay? That's the topic. But anyway, I told you we're gonna deal with Revit and some more BIM applications as an introductory course. Why digital design and visualization, especially why 3D computer graphics? Our course title is Digital Design and Visualization. Why visualization matters? Simply say, very pragmatic, very practical reason for enhancing your design visualization skills, okay? How to enhance your design technique, design representation techniques. Another one, for moving forward to advanced design computing issues such as BIM, okay? You have to know geometric modeling first and then move to information modeling approach, BIM approach, and even more advanced approaches, okay? Main focus is here, enhancing your design representation, design visualization skills, okay? Let's briefly take a look again, history of computer design. History of CAD is a history of how to understand design. What is design, okay? Around 50 years ago, when the Sketchpad, the first CAD system, okay, line drawing CAD system, computer system, invented, at that time, people believed that the design is a drawing of the product. That is why we are focusing on elevation, plans, perspective, or something, line drawings, okay? So geometric drafting in 2D was the CAD system at the time. But some smart people invented 3D surface-based model approach, okay? Surface-based 3D representation. It's 3D, okay? You can rotate this box. You can see top view, front view, section, and so on. Geometric surface modeling in 3D, that is so-called surface-based 3D model. Even smarter people suggested and implemented 3D solid modeling approach. Why solid? Think about this one. Surface-based 3D looking object, looking 3D. But surface doesn't have thickness. In other words, it's mathematical definition, not real object. But can you find zero thickness object in real world? There is nothing. There is nothing like that. In other words, in real world, even if it's very, very thin or very lightweight, anyway, it has thickness. It has weight, okay? So we need to solid fill in the definition of geometry. So that is solid model, realistic, okay? Even smarter people suggested and invented the parametric model. Okay, point line, they are all mathematical definition, something abstract, something unreal. It's not realistic. In real world, we are using width, depth, thickness, height. What if you want to control this one? Change higher height, and then this one going to be updated, okay? Not controlling vertices or lines and so on. The most advanced one is here. Entire rest of things are the part of this one. More information. What kind of information? Compositional, analytical, and fabrication representations of the product going to be part of this model. So that is building information modeling. This semester, we are still focusing on this one. What if you use only 2D CAD tools, 2D drawing tools? That's going to be here, but thankfully we are here. But the problem is it's exactly the same to SketchUp. But lots of powerful and predefined, well-defined aspects of design visualization things in 3D Max and related tools. So this is the focus of this semester. How about next semester? Rest of things, and this one also one part of next semester's digital design and BIM course. Okay. Anyway, this is the scope of this semester. Some part of others, of course, the subject, but not the main. Anyway, my point is here. Okay. Let's quickly review design mode we have learned before. Very simple. Mode of thought, your brain. No one can see your brain. Okay. What is inside of your head? Okay. It's not possible. Before you are saying something, you are drawing something, you are creating some computer file, visualization, or something else. Before doing that, no one can see your idea, but it's very still important to you guys. Take a look at the description. Next one is mode of expression, something to be visualized. Final stage, of course, mode of production. Okay. No need to say. Anyway, take a look. Visual equivalent. Visually equivalent to your design concept, design idea, design approach. Okay? Visualization is the most important thing you need to achieve in your design expression mode. Okay? How about design media? Designed by hand for several thousand years. Compared to human history, more than 99% of history used hand drawing, okay? Pencil or pens, whatever it is. But in this class, we are using computers. But I told you, just 40, 60 years ago, computer has invented CAD systems, just 40 years. Okay, your computer tool, 3D Max 2015, released 2 years ago. Okay. Anyway, we're going to use computers. Designed by pencil to computing, that's the change we encountered. The pencil is the most basic media of design. Nowadays, you can simply, quickly draw by hand for your design. Okay, that's your kind of primitive idea sketch or something. But this is design computing course. We have lots of IT, lots of technologies. We're going to use new media. That's why I call digital design media. Okay, you have to maximize the effect, the power of your media. Okay, your media in this room, in this class, of course, it's computers. You are using smartphones, tablets, some mobile devices, mostly for fun or for communicating with friends. But anyway, you can use some IT tools for your design, something productive things. Here is an example, student work, freshman work, okay? Freshman work. They didn't know any computer software for design, but they have learned SketchUp, V-Ray, some renderers, Photoshop, and they could make this kind of visualization. How about this one? Jewish Museum, Slipbox, something not 100%, but anyway, looking realistic visualizations. Line stroke, SketchUp, visualization styles. I assume that you are already well known to design visualization using Rhino, AutoCAD, SketchUp, V-Ray. But in this semester, 3D Max Design and Autodesk Material, Mental Ray, some technical aspects regarding such tools and Autodesk tools, some primitive introductory things about Autodesk Revit, and so on, okay? That's the scope. Last week, I showed you this one before. What you have to learn are listed up here. Some great phones, hardware, internet, software, operating systems, some fundamentals in engineering theory. But anyway, focus on fundamentals in the lecture. In the lecture, I'm gonna let you know what is the critical fundamentals of design computing theories, okay? We have midterm exam, November 21st. Regarding my lecture, okay? Based upon my lecture, you're gonna have the exam. In the lab exercise hours, I told you again and again, 3D Max design, Mental Ray, V-Ray, Photoshop, Intro to Revit, and possible some more applications. It's up to you. Anyway, that's the subject for the lab exercise. Even more things about design computing, such as 3D printing. In this semester, you're gonna be asked to print something, create something by 3D Max and print them out using 3D printers, laser scan, photogrammetry, virtual reality. They are one of the subjects we're gonna deal with in this semester, okay? Let's take a look at this 3D rendering, okay? This is kind of very famous image, okay? This is not a picture, of course, it's a computer-generated image, render image. So if you click this, you can find out some website link. 3D rendering on the Wikipedia. There is the image, okay? Actually, it's not important, but anyway, Gill's trend with the Ray using radiosity. Radiosity is one of the technologies available nowadays in photorealistic rendering, something like this. Even if it's not kind of 3D Max generated, anyway, by using 3D Max and recently developed technologies, you can make this kind of visualization. Even today, actually. But anyway, lots of more and sophisticated handling you need. But my point here is, nowadays computer visualization technique is very, very advanced. What you need to do is take maximum advantages of existing techniques, okay? Is this a picture or computer graphic? Or it doesn't matter? My answer is it doesn't matter, okay? Of course, this is computer generated. This is IKEA product. No matter what it is, no problem, because visualization nowadays, there is no difference between real picture and computer generated. Sometimes computer generated looking much realistic than pictures. Anyway, take a look this interior. Some type of office layout. Is this a picture? Of course, it's computer generated. How about this? Kitchen area. Computer generated. IKEA. IKEA provides you lots of some PDF file or online brochure or even print out brochure for their products using computer graphics, okay? Not real product. Why they made this kind of computer graphics? Take a look. Same product, IKEA product for kitchen, okay? Kitchen cabinets. But IKEA is kind of global company. Something for Northern America, something for Asia market, something for European style market. Some different faucets, different layouts, a little bit different things fit to local environment. What if they have to take pictures for all of them? They have to remove and reinstall, take picture again and again. But thanks to computer graphics, they made them instantly, okay? Much cheaper than real picture. So take a look. This guy, I'm not sure he's working in there. Anyway, he's in charge of making this kind of real visualization. If you click this link, I just placed a reference for this one, okay? In the Visual News website, take a look, the image that I show you, okay? Okay, 75% of IKEA product photographs are actually computer generated, okay? The chair I show you and the reason why they use this kind of computer graphics and so on, okay? So, in this class, like this guy, we are going to use Autodesk design, 3D Max Design 2015 because it's the latest version in design model, okay? Not 2016 or 17, 2015. V-Ray, Photoshop, NVIDIA Mental Ray. Do you know what is NVIDIA? The company name NVIDIA is very, very familiar to gamers. If you playing game, you may know NVIDIA. NVIDIA GeForce, have you heard of GeForce graphics card? The GeForce graphics card is one of the faster computer graphic system and computer graphic GPU, engine, GPU, cardboard for computer graphics, okay? Anyway, the company NVIDIA bought Mental Ray, and Mental Ray is NVIDIA software, anyway, thanks to Mental Ray and amount of well-defined professionals material in Autodesk material, you can make very photorealistic renderings and so on. Take a look. This one is actually not 100% photorealistic, but anyway, looking photorealistic, okay? But actually, I made this image in 3 minutes in 3D Max. Just 3 minutes you need, okay? Place cylinder and cylinder extraction in order to make this one is looking glass. Plane and torus nut, lights, render. And you can get this kind of image. How about this one? Last week I showed you similar example. Teapot with ceramic material, floor plane using wood floor, chrome balls, and 3 lights. 2 white color lights, actually 3 lights and 1 yellow color lights, okay? But the dark black background, simply because the background of this image, just nothing, just black background. That is why this one reflects black, okay? So just 5 minutes for making this visualization. My point here is computer graphics, rendering technique, really advanced. Take a look, this example, computer graphics, another computer graphics, even by using SketchUp, easy to use application SketchUp and V-Ray, you can make this kind of scene, okay? That's my point, very easy to use. But I show you actually very photorealistic images. Is your photorealistic visualization always top priority? What I mean is, photorealistic rendering is always your top priority? My answer is, of course, no, okay? Your idea from your brain composed of your computer model, computational model, 3D Max file, SketchUp file, Rhino file, Revit file, whatever it is, and then it's going to be visualized, lots of visualization. So what should be realistic? Your sketch, your 3D, your picture, your animation, sometimes they are visual, photorealistic. But I told you, there is intermediate computer model. So your computer model is supposed to be realistic. In other words, you should try your best for making your computational model, intermediate model, realistic, not the outputs, okay? Without this model, directly from your brain, from your idea to this outputs, very recursive, very time-consuming, tedious, never-ending task you have to do, okay? Your computational model is kind of very realistic and well-made. Your output sometimes line drawing, shaded, sometimes photorealistic rendering, sometimes very nice representation, sometimes very abstract, line stroke based images, sometimes floor plans, and so on. Okay? Semantic integrity, that is the thing, the concept you have to be aware of. For your building model, for your computational model, that one has your mini world. What is world? What is universe of this course? What is UOD? Your definition of your world. Okay? Okay, when you design your building, think about you are designing your home, your new house. Is there Star Wars characters? Is there some other buildings? Is there some, how can I say, some monsters in your universe of this course? Of course not, okay? Your well-defined universe first, and your object of your interest supposed to be same to your real-world object, okay? This is semantic integrity. Semantically same with your real-world object you are pursuing in terms of your mini-world, in terms of your university of this course. This university, sorry, not university, it's universe, okay? This universe doesn't need to be same to real-world universe. Real-world universe, what is this? What is that? This university. This one contains anything. This one has 100% things we created, what Mother Nature, also one part of it. Anyway, well-defined your mini world, your universe, that is the important thing you need to take care of. Semantics. This CAD model looks very just line drawing and color shade, that's it. But this one is photorealistic. Which one is better? In terms of visualization, this is looking better. But what if this one has any related information, but this one has amount of information, data, on top of this image or behind this image? This one has semantic integrity, okay? Semantics. So photorealistic visualization is not always the solution. Architecturally effective visualization, which has semantic integrity, is of importance. That's the topic. That's the thing I like to emphasize, okay? Let's quickly review something about rendering. Actually, you have learned rendering aspects before. 3D visualization by computers. Let's take a look. Rendering is all about lights, okay? Okay, take a look, the series of very simplified image. How about this one? Is this rendering? Is this rendering? No? Why no? This is rendering, okay? This is rendering in line stroke style. I told you, rendering, what is rendering? What is the literal meaning of render? If you open dictionary and find out render means visual representation by hand, by some type of media, whatever. So this is rendering, but not photorealistic. It's line stroke render. How about this one? Color fill render. How about this? Shaded with shadow casting. How about this one? Entire thing with texture map. How about this one? Ray traced, okay? So something advanced, but anyway, all of those visualizations are rendering. Photorealistic is here, but anyway, they are still effective render, okay? Line stroke render and so on. The right text here simply explains you something about computer rendering. Three main things: lighting, your object, camera, okay? Lighting, very important, but SketchUp, Rhino, 3D Max, they have their own default light. But default light is super low quality. That is why you need to place your own light system, because they have much better quality. Anyway, you need to know something about light. Also, you have to know something about camera. It's exactly same to real world camera. If you are very well known to DSLR camera, it's very good, very applicable to real camera object in 3D Max or some other tools. Camera is still very important. How about object? Of course, it's really critical. Your object, what is diffuse? The surface color, surface material, as it seen by your eyes, okay? Intensity, texture map, shadow casting, ambient occlusion, lots of sub-objects, sub-things you have to know. Reflection, refraction, caustics, lots of things you need to know. How many? Take a look this one. You have to know those technical keywords for computer rendering. But no worries, not that complicated. Even if it's looking complicated, if you understand the mechanism, nothing. And another good news is, this is something about V-Ray in SketchUp you have learned last year. In Mental Ray, there are amount of presets. Preset means predefined material. Defined by whom? Student? No. Experts. Some professionals already defined to provide you this kind of thing. You don't need to worry about those things. Today's lab exercise, you will find out how it is easy to use and powerful, okay? Take a look this one. Lighting source, reflection, but no caustics. This is caustics, okay? And take a look. Some type of ambient occlusion. This is ray tracing, okay? There is a ray, okay? Ray penetrating this glass make another lighting effect like this. Reflection from this green color, but there is no green effect. This is not ray tracing, okay? This is radiosity-based ray tracing technology applied. Something like Mental Ray. Anyway, as a default, we're going to use Mental Ray. We use this one, okay? Very powerful preset renders and very powerful Autodesk material. That is what you're going to use today, okay? Okay, let's finish the lecture and move to the lab exercise, installation and quick preview.